N points are chosen randomly on the circumference of a circle. What is the probability that all lie in the same semicircle? This problem is difficult to answer if you follow the traditional way of continuous probability, but with some trick we can easily solve this problem. Alright. So before watching this video, you try on your way and try to understand the difficulties. Then later you can understand the solution. So there are n points, right? And this is your circle. The 10 points are 1, 2, 3, so on n. For example, they are distributed like this 1, 2, 3, 4, so on n. Alright. So now see, this is a semicircle, they belong, right? Or maybe I can say this is a semicircle, they belong. So definitely they belongs to same semicircle. You can see it, correct? So we have to find out the probability for that. Okay. Now let me take this circle, right? So let's denote an event E1. Okay. So that event E1, I describe what it is. In that, 1 is the leading point. That means I am imagining all the possibilities where, or all the patterns where 1 is the first point when I view from the clockwise direction. Okay, this is your clockwise direction. In the clockwise direction, if 1 is the leading point, that means 2, 3, 4, 5 cannot appear before 1. And they all belongs to same semicircle. That is an event E1. What is the probability for that? Alright, you understand that point? Okay. So for example, this is your circle and this is the point 1 which is leading. Alright. So all other points should belong to the same semicircle like where 1 belongs to. So then definitely this 2 cannot be here because in the clockwise direction 1 should lead, then all the points should be after 1, 2, 3, so on. Correct? Okay. Now can I say one thing? To happen that event, definitely they all should belong to this area, correct? This area. Okay. What is the probability for that? So point 2, let's focus on point 2. This point 2 can be anywhere in the circumference. So to happen event number 1, definitely that cannot be in this area, correct? That means this in this half of the circumference. What is the probability that it is in this circumference, this half circumference 1 by 2, correct? Similarly for point 3 also there is a 1 by 2 probability. So to happen event number 1, what is event number 1? Event number 1 is having all the 10 points on the same semicircle where 1 is the leading point. 1 is the leading point. For that point 2, point 3, all these points should belong to this half of the this part of the semicircle or this part of the circle. So what is the probability that they all belongs to the same semicircle? 1 by 2, 1 by 2, 1 by 2, so on n minus 1 times. Alright. So that would be 1 by 2 whole to the power of n minus 1. Now, but there are some other possibilities, that is like event number 2, event number 3, event number so on en. What is event number 2? To have all the points on the same semicircle, that points might be led by 2 also. That means leading point might be 2, leading point might be 3, so on. So finally, so if all the points belongs to same semicircle, they all might lead by 1 or might lead by 2, so on, might lead by n. So these are all events. Now there is one important property. If you see, they are all mutually disjoint events. If they all belongs to same semicircle, and if they are led by 1, they cannot be led by 2, they cannot be led by 3, so on, correct? So that's why they are all mutually disjoint. Now if you want to find out the probability, our probability, we have to find out the probability of E1 union, E2 union, so on En. That is equal to probability of E1 plus probability of E2 plus probability of E3, so on, probability of En. So these are the only events we require, right? They all should belong to same semicircle and either they should be led by 1 or 2 or so on n. Some students have this question, if they think, that is, sir, if 1 is leading, alright, then why you have taken this semicircle? So this circle, that semicircle might be, I'll show sir, That semicircle might be from here to here, sir. Why are you not considering this semicircle? Why are you not, sir, considering this semicircle? The reason is, let's say you are considering this semicircle. That means you are telling that points can be in this area, correct? But that is not possible. If there is any point here, then that is not called that one is leading there, right? If one is leading, definitely this area cannot be used. So that's why only this area is a potential area, correct? That means all the points should lie on this semicircle only. That's why, so we are doing right. So probability of E1 equal to 1 by 2 to the power of n minus 1, right? Similarly, probability of E2 is 1 by 2 whole to the power of n minus 1. So on, if you sum all of them, then you get n times 1 by 2 whole to the power of n minus 1. That is n by 2 to the power of n minus 1. That's it.